Evening, students. So this is going to be a small lecture on vectors. Okay, and before going into the details of the vectors, let me first give you a brief about what is a vector quantity and where are these vectors used. Okay, so primarily it is science in which you use it. You use it in physics, you use it in mathematics. Okay, vector quantities are those quantities which have magnitude as well as direction. So whenever we talk about a vector quantity, suppose naturally its opposite term is scalar. So vector quantity versus scalar quantity, this is what you usually study. Okay, so scalar quantities are those quantities which will be represented only by the magnitude. Direction here is not significant, not important. Okay, so if any physical quantity can be fully and completely described only using magnitude, then that physical quantity can be called as a scalar quantity. And you know the example for these scalar quantities are quite easy to give. So we have mass. It's not necessary for you to specify that a person has this much mass or a body has this much mass in a particular direction. No, that is not significant. Only the value is significant, and therefore these are scalar quantities. Similarly, you have time and all these. Okay, so this was just a beginning aspect of it. Now coming to the vector quantity, which is the topic. So we will have both magnitude plus direction. Okay, so along with the value, so when we talk about magnitude, we talk about the value or the amount. Okay, and in terms of direction, you usually give a particular direction. Let's say, for example, if you talk about velocity, for example. Okay, so now velocity will have both a value plus a particular direction in which the body is moving. Okay, so that is obviously the sense of direction. Okay, so these value and direction, or magnitude as well as direction, both these things are important in order to fully describe a vector physical quantity. Okay, so that is the idea of a vector quantity. Now coming down to the term vectors, what are vectors and what are the types of vectors, and so on and so forth. So let's talk about a few aspects of this as well. Now majorly you will have this topic covered in 11th and 12th mathematics as well as physics, but just to give you a brief idea, at 9th and 10th level also. So we have vectors. Now how do you usually represent a vector? So let's say, for example, now since it's a vector, so it is supposed to have both magnitude, okay, as well as direction. Okay, so both these things are going to be present in a vector. Okay, now let's say that we are denoting the vector by a capital letter A. Okay, now there is a particular way in which a vector is written. You may be able to write a scalar quantity simply by writing the letter A, but it will not be the same case when you want to represent a vector A. So whenever you want to represent a vector A, you will write it with an arrow at the top, either like this or you will write it like this. Okay, so this is the first major difference in terms of how you represent a vector. Okay, now this vector may not necessarily only be this capital A, and you can have a vector Z, you can have a vector A, and so on and so forth. Okay, now so the essential part here is that these arrows at the top, they are indicating the direction, that this particular quantity, this particular physical quantity has direction also along with the magnitude. Okay. Then the second thing that you have to know about about the representation of a vector quantity is that suppose I have this vector A and I have this vector B, and this is how I represent this, and this is how I represent this. Okay, so usually the idea here is the reason why we have made arrows of different sizes is to denote that these vectors, although both these are vector quantities, but these vectors are different in one way, in a particular way. Now what is that particular way? That is that the length of these vectors, as you see, the length of the line of this vector and the length of the line of this vector, they are different. In fact, this is greater. The line length in this particular case is greater, which suggests that the magnitude of vector A is greater than the magnitude of vector B. Okay, so first thing about a vector representation is that along with the letter you have an arrow at the top, number one. Number two, the length of the line of that arrow will actually be emphasizing on the magnitude of the vector. So the longer the line, more the magnitude of that vector. This is the second thing that you need to remember about vectors. Then comes the third thing, and that is, what if you want to know the magnitude, let's say magnitude of vector A. Okay, now we all have understood that this is the way we represent a vector A. Okay, so we will write the letter A and we will have an arrow at the top. So this represents both magnitude as well as direction. But what if you want to know only the magnitude of this vector A? So the representation of this magnitude will be in terms of the absolute value. So this is also known as the absolute value of the vector A. Okay, so the magnitude of vector A is nothing but the absolute value of the vector A, and that is usually represented with two bars like this alongside, the vertical bars alongside, which basically, if you have studied mathematics and the modulus function, you will understand that these two symbols, these two bars that we draw alongside, parallel bars, vertical bars, and in between you have that vector. So these bars actually give you the magnitude. Okay, they give you the modulus. Modulus means the magnitude of that particular vector. So whenever you want to represent the vector as a whole, then you will only write the letter with an arrow at the top. But if you want to represent only the magnitude of that vector, then you will represent it with the help of these two vertical bars, which denote the absolute value of the vector, or in other words, the magnitude of that vector. Okay, now, so this was as far as the various representative methods were to be discussed. So these were different ways to represent different things about a vector. Now if somebody wants to know what are the different kinds of vectors, let's say for example, there are some common ones that we use. So let's say we have one as a free vector. Okay, then we have let's say a localized vector. So now what are these? Now if you will read these two words, free and localized, both are vectors naturally. One is free and one is localized. So what are free vectors? Essentially, you see, free vectors are those vectors which can be transferred parallelly. Let's say for example, if you show a vector like this, okay, now this vector, let's say this is vector A. So this may have some magnitude, this may have some direction. So that same vector, if you can displace this vector from this particular location parallelly to any other location, but keeping the direction same. Let's say for example, I do this. Now you can see that the length of this vector as well as the direction of this vector is still the same. The only difference is that it has been moved parallelly along the direction. Okay, so let's say this, or for that matter this. So these are all representations of free vector. So free vector is any such vector which can move about parallel to its original location. Okay, so essentially, what is the importance of a free vector? It is independent of the point of application or the direction of application. Okay, so you can apply this vector at this point, you can apply this vector at this point, at this point, at this point. So there won't be any change in terms of the result that it produces. Okay, so one such example of this free vector is the velocity vector. Okay, now the localized vector is quite opposite to what we discussed just now. Localized vector, let's say for example, if you want to discuss, let's say we have a rock formation here. Okay, and we want to apply, let's say, a particular vector force, let's say for example at this particular location on this particular rock. Okay, now the same vector, if it is applied over here at this particular position, do you think the result, the end effect of the application of these vectors on this particular shape, they will be same? Certainly not. This application, this point of application will bring about a far more let's say movement or displacement of this particular piece of rock or whatever. Okay, so the same vector, if it is applied at a different location, see the location here is different, this is a different location, this is a different location where the vector has been applied. The effect of the application of vectors at different places, they are going to be different. Okay, because the location, the application point is different in case of localized vectors. Okay, so in essence, if you want to draw some conclusions from the study of free vector and localized vector, what is the important point to keep in mind? That free vectors, they are independent of the point of application or the line of application. They can be applied anywhere. You see, this was the example of the free vector. Okay, so they can be applied parallelly at any different locations, okay, at a number of locations without having any significant difference in terms of the result. Whereas localized vectors, in localized vectors, you have a very important significance of where the point of application of the vector is. So depending upon the point of application, you get a different end result. Okay, so these are localized vectors. Then comes the third one, which is equal vectors. So what probably could be the definition or the meaning of equal vectors? So the magnitude of equal vectors will be the same. The magnitude and the direction both will be same in case of equal vectors. So you can write it down over here. Both magnitude and direction of vectors, which is equal vectors, is same. Okay, is same. So when we talk about equal vectors, we will keep in mind that such vectors will have the same value also, same magnitude also, or same modulus and the same direction. So if I draw, let's say for example, this and this, these two vectors, so are they equal vectors? Yes, they are equal vectors because they have the same magnitude, because the length of the line is same, and you can see that they have the same direction. So these are equal vectors. Now, are these equal vectors? No, these will not be counted as equal vectors, because although you can see the magnitudes are same, but their directions are quite different. Similarly, you can have a vector like this and you can have a vector like this. Although the magnitudes are same, but their directions are opposite, so this also does not qualify as equal vectors. Similarly, you can give another example, let's say like this. Now here you can see that the direction of both these vectors is the same. It's towards the right hand side of this, but you can see that the magnitude of this vector is much lesser than the magnitude of this vector. Therefore these vectors are also not equal vectors. So whenever they are not equal, they are unequal. Okay, so there comes your next category. You can write down the fourth category, which is unequal vectors. Okay, so these are unequal vectors. So what is that example? This is one example, this is one example, and this is one example of unequal vectors. So how can two vectors be unequal? Either their magnitudes can be unequal or their directions can be different. Okay, so any one of the magnitude and direction, if they are different, then we will classify them under unequal vectors. So for two vectors to be equal vectors, both magnitude and direction of them have to be same. Localized vectors, they actually depend upon the location of application, and free vectors, they can be transferred along the parallel lines. Okay, so these are the four types. Then comes the next. So the next category is of zero vectors. Okay, zero vectors. So what is so special about zero vectors? Their magnitude is 0. Okay, these are also known as null vectors. Okay, these are also known as null vectors or zero vectors. Okay, the reason why they are called zero vectors is because their magnitude is 0, so their direction can be. So how will you represent a zero vector? You see, you can't really represent a zero vector with the help of this symbol, with where the line has a particular length. No, because I already told you that the length of the line of the vector symbol over here, the arrow at the top, that actually signifies the magnitude of the vector, and here we are saying that the vector has no magnitude, therefore it will be represented with a simple dot. Okay, now the direction can be any one. Direction is it's actually independent of the direction. Direction may be direction for a zero vector may be any direction. It can be a number of directions like this, but the magnitude will be 0. Similarly, we have the last classification here as unit vector. Okay, the unit vector. So what is a unit vector? As the name suggests, its magnitude will be 1. Okay, so magnitude will be 1 or unity. So how will you represent a unit vector, and essentially how do you get a vector which has a magnitude of 1? Let's say, for example, we have a vector A. Okay, we have a vector A, and this vector actually has some magnitude as well as the direction. Okay, so how do you convert this into a unit vector? You see, generally the unit vector is represented by a particular letter, and you have a cap at the top. Okay, this is called as a cap or a hat. Okay, so this actually represents a unit vector A. Similarly, you can have a unit vector B like this, you can have a unit vector C like this. So this cap at the top essentially means that this is a unit vector, and unit vector means that its magnitude is 1. So how do you get that? So essentially we were discussing about this particular case. Suppose we have a vector A which has some magnitude and it has some direction. Now what will happen if I do this? The vector, and I am dividing this vector with the magnitude of the vector. So essentially what is going to happen is, let's understand it like this. This in the numerator is the vector itself. Now when I say vector itself, then it has both magnitude, which is not 1, so it has some magnitude, and it has some direction. Okay, now imagine if the magnitude is, let's say, 20 units, and I divide the vector by that 20 units. Okay, so what am I going to get in terms of the value? 20 and 20 will get cancelled, so the magnitude will become 1, and the direction will continue to remain as the same as the original vector. So let's say the original vector A had this particular direction. So the end result, after dividing the vector by the magnitude of that vector, the value of the vector will become 1, and it will still have that same direction. So essentially, what is this denominator that we are dividing this with? So this denominator, if you remember, I used it in the same lecture in the beginning. I told you that these two vertical bars alongside the vector, they actually signify that we are only picking up the magnitude of this vector. Okay, so, or the modulus of the vector, or the value of that vector. So what are we doing here? We are dividing the vector which carries magnitude and direction by only the magnitude. So the magnitude and magnitude gets cancelled, and you are left with only the direction. So this becomes a vector A, which is a unit vector. So it only has a specific direction, but the value has become 1. This is a unit vector. So I hope you have got a fair bit of an idea of what are the different types of vectors and how are they represented, and what is their significance in terms of their usage. Thank you.